Alright, so the first thing we covered was the Pythagorean theorem. You do have a formula for this. We've covered it multiple times, and your formula is a squared plus b squared equals c squared. A and B are the legs of the triangle, C is the hypotenuse, but what's really important is C is across from the right angle, or the 90 degrees, and it's also the longest leg or longest side of the triangle. So when you get to a problem, the first thing you need to do is label your A, B, and C. So we're always going to start with C. I'm going to go across from the 90 degrees. I'm going to label that C. Now your A and B don't matter after that, so I'm just going to put 3 as A and 4 as B. And I'm going to use that Pythagorean theorem that we just talked about, a squared plus b squared equals c squared, and plug stuff in. So now instead of a squared, I'm going to have 4 squared plus 3 squared equals, and since c is x, I'm going to plug it in as x squared. Whenever both of your numbers are on the same side, so I have 4 squared and 3 squared, I can plug that into my calculator, or you can do the math. 4 squared plus 3 squared is 16 plus 9. So this is actually 25 equals x squared. But we need for it to be just x by itself, so the last step we're going to do is take the square root of both sides. When I take the square root of 25, I get 5. When I take the square root of x squared, I get x. And so I find out that x is equal to 5, and that's my final answer. Now, example 2, we're going to do the same process. I'm going to write out my formula, a squared plus b squared equals c squared. I'm going to go over to my triangle and label everything. So across from the 90 is c, and then the other two are a and b. And now I'm going to fill everything into my formula. Instead of a squared, I'm going to have x squared plus b squared is going to be 12 squared, and it's equal to c squared, which is 15 squared. Now, on the last one, I had both numbers on the same side, so I could plug it into the calculator. I don't have that here. What I have to do is actually move this 12 squared to the other side. So I'm going to subtract 12 squared from both sides. It cancels out here, and I'm left with x squared is equal to 15 squared minus 12 squared. We cannot combine them. Since both of my numbers are on the same side now, I can plug this straight into the calculator. When I plug 15 squared minus 12 squared into the calculator, I get 81. It's still x squared, so I need to take the square root of both sides. And when I do that, I find out that x is equal to 9. Example 3 is for you to try on your own. Remember, you want to write out your formula, label your sides, and then start plugging in. So the converse of the Pythagorean tells us whether a triangle is an acute, obtuse, or right triangle. And there are 3 things that can happen. We're still using the Pythagorean theorem, but if we have a squared plus b squared is less than c squared, that tells us that we have an obtuse triangle. The next situation we could have is a squared plus b squared is greater than c squared, and this would be an acute triangle. And the last situation we have is a squared plus b squared is equal to c squared, and this is a right triangle. But you do have to remember in the very beginning to check to see if it's a triangle, because sometimes they will give you links that just aren't even triangles in the beginning, and if you can't do that like we did in our triangle inequalities unit, then you don't move on to the next step. So the first thing I do here is I take my 2 smallest sides. So my 2 smallest sides here are 5 and 12, so I add those together, and they have to be bigger than 16. So 5 plus 12 is 17, and I ask myself, is 17 bigger than 16? It is, so I go on to the next step. Now again, I need to know what A, B, and C are. C is always going to be the biggest number, and then A and B don't matter after that. So I'm going to plug it in as 5 squared plus 12 squared, and I'm going to compare it to 16 squared. You're going to plug this left side of the calculator in and get a number. And when you plug that in, you get 169. You're going to do the same thing with the right side. We're going to plug in 16 squared. And when you do, you end up with 256. So we need to compare 169 to 256, and we need to see if it's less than, greater than, or equal to 256, and 169 is less than. So what I do is I go back to this first one, and I'm looking for a squared plus b squared is less than c squared. When I look here, I see that it's this first one, so that tells me that this triangle would be an obtuse triangle. So you're going to do the same exact steps for number 2 and number 3 and tell us what kind of triangle it would be. After we did the Pythagorean theorem stuff, we got into actually starting trig. And the first thing we learned was how to label sides. So when we're labeling sides, the first thing you're going to label is the hypotenuse. And we're going to label the hypotenuse with an H. And you need to know that you're always going for across from the right angle. After you've labeled the hypotenuse, you're going to label the opposite side. And we're going to label that with an O. And this one is across from the angle of interest. So that's how we associate those two. And the final one we have is the adjacent side. All you need to know is we're labeling this with an A. And if you label the hypotenuse and then the opposite before it, the last one has to be the A side. So I told you the first thing we're going to do is label the hypotenuse. So I'm going to the right angle, so the little box in the picture. I'm drawing my arrow across, and that tells me the side with 30 is H. Now, here, I'm going to tell you that your angle of interest is angle X. We'll tell you it, we'll give you in the problem, anything like that. So we're going to mark it. Now, I'm going to go across from my angle of interest, and that tells me the side with 18 is O. There's only one side left and one side left to label, which is the 24. So I know that I'm labeling that with an A. This labeling side step is super important moving on to the next problems we have for trig, because if you can't label the sides, you really can't do much else. Now with reduced ratios, there are some trig ratios we learned. With reduced ratios, the first thing you're going to do still is label your sides, but you need to make sure that you mark your angle of interest too. After you've labeled your sides, you're going to write a ratio based on trig. And at this point, we introduce you to 3 trig ratios. The first one we talked about was sine. And what sine is we take the opposite side over the hypotenuse side. So this right side right here, this little fraction, that's the ratio we're talking about. After sine, we have cosine. We take the adjacent side over the hypotenuse. And the final one we have is tangent. And we take the opposite side over the adjacent side. So this problem tells me I want to look at the tangent of Z. So I'm going to go to my triangle and I'm going to mark my angle of interest, and that's Z. Whatever is right here next to your trig ratio is your angle of interest. I'm not going to label all my sides, so I'm going to go across from the hypotenuse, and that tells me this is my H. I'm now going to go across from the angle of interest. That tells me this is my O, and the last side has to be my A. Now, my tangent of Z. I just told you that tangent was the opposite side over the adjacent side. So I'm going to take those numbers now. My O is 28 over my adjacent is 21. I do need to reduce this if possible. You can use the button above the 7 on your calculator. You can do it by hand. This does reduce down, and it ends up being 4 over 3. So tangent of Z is 4 over 3. When we ask you for a reduced ratio, we're asking you for this fraction. Now, the last 2 things we talked about were trig and inverse trig. The first one was finding missing sides, and that's just regular trig. We do have an equation for that where we take the trig ratio, we put in parentheses the angle of interest, and it's equal to the ratio of sides. This trig ratio right here is where you would put sine, cosine, or tangent. Right here, angle of interest is going to be a number, a degree, and your ratio of sides is either going to be O over H if it's sine, A over H if it's cosine, or O over A if it's tangent. So we're still going to follow the same steps that we've been using. We're first going to mark our angle of interest. Your angle of interest in these problems is the angle other than the 90 degrees. So right here, 19 degrees is my angle of interest. I'm now going to label my sides. I'm going to label my H first, across from the 90. I'm going to go across from the angle of interest and label that O, and my last side is A. Now, one of these sides has nothing on it. It doesn't have a number. It doesn't have X. Whatever side is completely blank, we want to mark out we're not using. So when I look at this, the side that's blank is the A. I'm not using A. Now, I ask myself, the sides that I have left are O and H. So I want to come over here to my trig ratios I just talked about earlier and see which side uses O and H, the opposite and the hypotenuse. And when I look, I find out it's sine. So I need to set my equation up like we just talked about, the trig ratio, so sine of the angle of interest, 19, is equal to O over H. And I'm going to plug in what I know O and H are now. So sine of 19 is equal to my O is X over my H is 19. Now, whatever is on the bottom of this fraction, we're actually going to move to the front. So when I move that to the front, I now have 19 sine of 19 is equal to X. Once X is by itself like it is here, it's just X equals something, you get to plug this whole side into the calculator. So you need to plug 19 sine of 19 into the calculator. And when you plug that in, you should get 6.186. So you do have to use some of your rounding skills here, and I find out that's what X is equal to. So if you notice here, this is a situation when X is on top. We move the bottom to the front and plug into the calculator. There is a second situation that we're going to go over next. So we're skipping down to example 3. We're going to do the same exact steps. I find my angle of interest is 61, so I mark it. I label all my sides. I have my H, I have my O, and I have A. I mark out the blank side, which is O, and that tells me I have A and H left, which tells me that I am using cosine. So cosine of 61 is equal to A over H. Cosine of 61 is equal to 17 over X. So same thing here. We're going to take that X and we're going to move it in front. I now have X cosine of 61 is equal to 17. But X is not by itself. So if I had something like 2X equals 12, I'd actually go and divide both sides by 2 and find out that X is equal to 6. So what I did here was I divided by anything in front of the X. We're going to do the same thing over here. I'm dividing by anything touching the X. So I'm dividing both sides by cosine of 61. What that does here is it cancels out, and I'm just left with X equals 17 divided by cosine of 61. My X is by itself, so in your calculator, you're going to plug in 17 divided by cosine of 61. And you should get 35.066. The last thing I did was inverse trig, and all that is the opposite, so this is when we're finding missing angles. The equation for this would be the trig ratio, but with a little -1 up top. If you were to hit each trig button, so sine, cosine, and tangent twice, it would bring that little -1 up. And on the inside, it's the ratio of sides. So this is just straight calculator work. I'm going to do one example. We do the same steps on this triangle. We mark our angle of interest first, which is this blank one. And then you label your sides as H, O, and A still. We mark out our blank sides, so that is A here. And so I'm using O and H, which tells me I'm using sine. But when I write my equation, I have sine inverse of O over H. So sine inverse of 12 over 33. And you're going to plug this straight into your calculator. And you get 21 degrees. You're responsible for all the blank problems. So there's 1, 2, 3, 4, 5, 6 for you to do on your own.